Hello and welcome. In this video, we're going to take another look at our Matlab while loops, and specifically, we are going to look at how to populate a vector or one-dimensional array using a while loop. This video assumes that you've been following along with some of the fundamentals of the Matlab programming language and specifically have some familiarity with how while loops work, as well as how vectors are accessed and updated. So to begin with, we're going to jump straight into some examples. I'll talk through each of the examples, and then I'll talk to you about some pros and cons of each of them as we go along. But what we're going to do first is we're going to revisit one of our older examples. And this is one that we've looked at both in the while loop as well as in the for loop. Please note this video does not assume that you necessarily have worked with the for loops. If anything, it's good to go back and look at both of them, but we are going to be focusing solely on while loops. Now, the example we're going to start off with is going to be to calculate the area for a sequence of values for the radius, in this case for a circle. And so the idea is that we want to be able to calculate and store all of the areas associated with a sequence of radii. Now, we could do this with a vector, but if anything, we want to see now how a while loop can be used in addition to just our basic vector operations in Matlab. And so what we'll do is we'll start off then with a radius, and we're going to use it to calculate the area. And then ultimately, we are going to store it in a vector called areas. So much like with the earlier example, we need to start off by creating a radius variable. We're going to set it to an initial value of 1. I am going to go ahead and use 1.0, even though it doesn't technically really matter, because in both cases, whether it's 1 or 1.0, it's still going to be a double. But if anything, you're going to see why in just a second that this approach is going to become problematic. We'll start off with our while loop, saying while radius is less than or equal to 10. Again, I'm going to go ahead and use the 10.0. Always remember to go ahead and throw in the end immediately when writing the while loop. And then what we want to do is we want to calculate the area. Notice it's singular, and that's just going to be equal to pi times the radius squared. And again, I'm going to go ahead and use the parentheses, not because they're required, but more just because it's easier to appreciate what's going on. Grouping kind of helps in reading the code. And then what we're going to do is we're going to then simply display, using our sprintf, the value for the radius. And I'm going to just go ahead and continue to use our %.4f, kind of arbitrary, but again, it gives a nice format. And then also the area is equal to %.4f. And then for that first placeholder, we simply put in the radius as well as the area. Now, we've already done this before. As a matter of fact, I've already mentioned this, that we just kind of want to ignore the combination of the warning with the combination of the display and the sprintf. There's no problems with that. You can alternatively use fprintf if you would like to. But now what we want to do is we want to store that individually calculated area in a vector called areas. And in order to be able to do this, first thing that we want to do is we want to go ahead and initialize this areas vector as a 0 by 0 vector of doubles. And you do that by simply setting it equal to the empty square brackets. And then what we're going to do is we are going to use that radius as an index for the areas vector. And we're then going to assign that singular area to it. And at this point, we can simply go ahead and run this. I'm going to go ahead and highlight and then either right click and evaluate selection or hit F9. And then you can see here that we once again have our infinite while loop. And if you recall from the earlier video, to be able to get us out of that, we hit Control C, and you should immediately see what is going wrong here. We failed to update the radius after each iteration. In other words, basically what's happening is we're keeping the radius constant. We're comparing it to the value of 10, and since the radius is never changing, we're never going to exit out of that while loop. Now, where you change this, it doesn't really matter as long as you do it after the calculation and after the display fprintf. We'll just do it as the last step here. Sorry about that. It's going to be radius is equal to radius plus 1. And again, we can play around with the indexing, and you'll see in just a second where the problem is. But to start off with, I'm going to use a whole number increment for the indexing. I'm going to go ahead and highlight and hit F9. Again, you can see that we have this nice table that starts off with radius equal to 1, going up to radius equal to 10, as well as the corresponding area. Now, so far, so good. But here is where the problem comes in. So let's say, for instance, that I go ahead and make a copy of this. I'm going to leave my original code alone so you can appreciate what I'm changing. And I change my increment. In other words, the delta between the radii here. So the idea is that I want to go from 1 to 1.5 to 2 to 2.5 and then so on. You can pick any sort of increment you'd like. This will discover the problem will be the same. But if we run this one more time, you can see here that you're going to get a warning that says array indices must be positive integers or logical values, and hence the problem. So what we want to do is we want to figure out how to keep track of the index, in other words, the number of iterations that the while loop runs, separate from any loop variable that we might be using. In other words, the control variable, the radius, drives the expression or drives the condition. Now, I'm going to show you how to do this a couple of different times here, but what we can do is we're going to go ahead and leave this alone. We're going to actually go ahead and leave the radius equal to radius plus 0.5 alone. And we're just going to go ahead and add one more variable in here. I'm going to start off with my index equal to 1. And then at the bottom of the while loop, I'm going to simply grow my index or increment my index by doing index equal index plus 1, much like we were increasing the radius. And then what we'll do here is we'll simply keep track of the location in the area's vector by substituting out the radius for the index. And again, I'm going to make a quick note here that we are substituting out then the radius for the index. And now, if I were to run this one more time, we sort of get the best of both worlds. In other words, we get the control associated with incrementing the radius. And you can see here that we have calculated values from 1 up to 10 by increments of 0.5. And there are the areas associated with it. But more importantly, if you come up here, you'll see that we now have a 1 by 19 double. And you'll notice that I stop at 10, and the 19th value out here is going to be the 314.1593. All right, so let's move on to another example. So this is the one that was for the areas. What we'd like to do is we'd like to revisit again an earlier example where we were looking at the balance of a checkbook or debit card, whatever you want to think of it as. And the idea is that we want to be able to keep track of how much money is being spent or how much is left, however you want to look at it. And we want to stop the while loop when you run out of money. Now, unlike in the earlier video where we just simply ran the loop and we didn't really care about the values, we printed them out to the console, but we really didn't keep track of them. This time around, I would like to be able to keep track of the balances as well as the purchases. And so what we want to do differently this time around is we'll start off with an initial balance of 100, just like we did before. But we're going to create a couple of additional variables here called balances. And the idea is that this is the balance after each purchase. And we also want to have a singular purchase, although arguably that's not really necessary. It's just more for us to be able to see how this works. And then we'll also keep track of all of the purchases. Now, because MATLAB lets us get away with a few things, technically we don't need to initialize the purchase variable. But again, I just want you to see all of the pieces of this as we go along. And again, we're still going to do this the way that we did it in the earlier video. So there are still going to be some flaws with this particular while loop that I will handle in a later video. For now, though, what we want to do is we want this while loop to run while the balance is greater than 0. And the idea is that we don't want to include 0 in this because if we are at 0, we shouldn't be purchasing anything anymore. Now, we did learn something from our earlier example with the radius and the area, in that we need a way to be able to store these values as we go along. And we can't just simply rely on one of the existing variables. And we, once again, will start off with an index. And I'm going to start off with setting this one equal to 1. And what we will do now is we will simply make a purchase using our randi function. Randi, if you recall from our earlier videos, just simply produces a random integer from 1 up to I max. In this case, my I max is 10. The idea is that it's essentially supposed to be a way of representing a random purchase at a convenience store or something along those lines. And yes, we can technically modify this to include decimal values as well. For right now, we're just going to deal with integer values. And then ultimately what we want to do is we want to take the balance and we want to subtract whatever that purchase is from the balance. And then you will see here that this is where our problem comes from. Now, unlike the earlier example where we simply just displayed using our printf, again, the purchase, and I'm going to go ahead and use the %2f format here, much like what you would do with money, as well as the balance equal to %.2f. What I'd also like to do is I'd like to add in here the index. And the index we will simply keep as a %d. So now what you've got is you've actually got 3 variables, the first one being the index, the second one being the purchase, and the third one being the balance. And the idea here is that every time this loop runs, I want to see those 3 pieces of information. Now, before we forget, we definitely want to go ahead and increment our index, because otherwise we are overwriting the values over and over again. But what we also want to do is we want to use that index to store the values in my balances vector as well as my purchases vector. And to do that, well, we do something similar to what we've done before. We simply say balances parentheses index is equal to whatever the balance is, and the purchases parentheses index is also equal to whatever that singular purchase is. And now we sort of have a record of the individual balance and the individual purchase after we exit the while loop and not only print it out to the console. Now, let's go ahead and highlight this one. And we can again hit F9. And you can see here that I have, in this case, I've made 15 purchases, of which arguably that last purchase was an unwise purchase because I did not have enough money in my account. That goes back to the problem that we're going to solve in a later video, and we'll take a look at a couple of different ways to solve that. But you could see here that my first purchase was $9, which brought my balance down to 91. Second, 10, brought me down to 81, and so on. But unlike before, we also have a 1/15 vector of the balances, which means it keeps track of all of the purchases in a row vector, as well as a purchases vector, which keeps track of all the purchase. I believe I misspoke just a second ago. The balances vector keeps track of the balance after each purchase. Now, it turns out that there's a couple of ways that you can go about doing this. So far, you've only seen one way, and that is I am creating this index variable and simply updating it as we go along. What I'd like to do is I'd like to redo this particular example, but this time around, I'm not going to use the index variable. So again, what we're going to do is we're going to see this as balance version 2. You can go ahead and copy and paste some of this if you'd like, particularly the balances, purchase, and purchases variables are all going to be reused, as well as the while loop is also going to be reused. We aren't going to fix it necessarily. And then lastly, the other thing that you want to go ahead and bring over is everything except for the increment of the index and anywhere that we have been using the index variable. In other words, the idea here is I want to do this a different way without relying on the index variable. And so what we're going to do is we're going to recognize that every time we make a purchase, we wish to store the purchase. And every time we change the balance, we wish to store the balance in their corresponding vectors. But to be able to do that, we have to know how many elements are already in those vectors. And this is where we can play a little bit of a trick with our length function. And so we'll start off first with our purchases vector. Notice I am using purchases plural. And then I simply check to see how long is the purchases vector to begin with by using the length function. And I simply add 1 to it and then assign the value of the current purchase. The idea is that this is going to grow now each iteration. And so this grows each iteration by 1. So the idea is it starts off as a 0 by 0. First time through, you increment by 1 and so on. So this is very similar in concept to using the index and incrementing the index. But what this does is this allows for you to do it without having that index variable. You do the exact same thing now with the balances vector. And again, what we're going to do is we're going to leverage the length of the balances, and we're going to add 1 to it. And that is simply going to be equal to the balance. And again, this is going to grow with each iteration. Now, I can put a little note here that says we can use the length, or what we can do is we can use the size function. We'll talk a little bit about the size function when we start looking at two-dimensional arrays again. But the idea is that both of these would work. You just simply need to specify whether you're looking at the number of rows or the number of columns, and that sort of will then impact which direction of the vector the ultimate results will be. All right, so let's again go ahead and highlight these lines here. And let's go ahead and run this one more time. I believe I have a typo here. Yes, I cannot use my index, at least not in the form in which I currently use it. So what we can do here is we can simply remove this. This doesn't really hurt us too much in this particular example. And then let's go ahead and run it one more time. You're probably curious as why we have index equal to 16. Well, that just happened to be the value that was left over from the last time I ran the loop. If I had cleared the workspace, we wouldn't have had that problem. And you can see here that basically by eliminating it, I just end up losing a little bit of information, but we can still keep track of that by just measuring the length of the existing purchases and balances vectors. But more importantly, you could see that a purchase of $1 will reduce the balance to 99, 3 will reduce it to 96. And accidentally, we actually did get down to $0 here. And you can see here by rerunning it that you get a different number of values each time. And then more importantly, you can come up here and you can look at either the purchases vector to look at all of the individual purchases, or the balances vector to see the balances after each of the purchases were made. So hopefully you found this video useful. If you've got any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.